let's dive into energy efficient Ethernet. Okay, so I'm going to give you a quick overview about EEE, cover some use cases, and then some details of what we support and what we don't and why that is. Then a bit of configuration, it's quite short actually, and a bit of troubleshooting. There's some good resources out there as well, which I've linked in that people can look at their own leisure. And then I'm going to go to a live demo to reinforce some of the config and troubleshooting. So the premise of energy efficient Ethernet is actually to save power in Ethernet networks. And how do we do that? Well, believe it or not, there are slices of idle time that we can take advantage of in Ethernet networks where we can power down our circuitry and actually save energy, but also enable us to push data out at the same time. I know Ethernet links are very chatty. You do a Wireshark and you see all that data flowing, but believe it or not, we can find times of idle moments in those links to save power effectively. So there's an IEEE standard 802.3 that we support, clause 78. Now you will actually see it may be referred as 802.3AZ, and but that's fine. We should be compatible with all of that. So one of the important things about energy efficient Ethernet, and you'll see this in some of the outputs that I show you, is a cycle that we call low power idle. And this is the method that we use to actually save power in the Ethernet link. And this is a layer 1 technology. So it's all done at the PHY level. Okay, another really important thing to understand is we're not alone in this game effectively. We work with a link partner. So our link partner is whoever's on the other side of the link. So typically where we're aiming this feature at is on endpoints. So switches, access points, computers, cameras, anything that supports energy efficient Ethernet, we can take advantage of cycles. Now, it's quite important to understand that you're not only saving energy in the switch when it powers down part of its circuitry, you're also saving energy in the endpoint as well. So you sort of getting two for the price of one effectively. Very important thing to know about our implementation at VE, but I mention it because it's our implementation. Other vendors will be similar. Okay, so you can only have EEE to be enabled and working on auto negotiation, so on link establishment. So it must be auto negotiated. You cannot have EEE work on the fly. So if you imagine you have your link up already, and if that link is then enabled for EEE, it's not going to operate in that feature is not going to operate. So it's really important to know that. But I'll talk about that a bit later anyway, but that's a big emphasis on that. So I guess one of the questions is why use EE, and is it really going to save us power? Well, there's been a couple of studies here that show that actually, yes, you can save energy in Ethernet networks. They've done it in Google data centers. They've done studies about it. You may also be asked by customers, do you support green features? Okay, so energy efficient Ethernet is one of those features. The customer may have some sort of IT operational expenditure that they want to cut down on. This could contribute towards it, and companies always have some form of green credentials that they want to be seen to be adhering to. So let's talk a bit about the low power idle part that I mentioned earlier. So in low power idle, you've got momentary bits of idleness where you're not sending data. Then you have active parts where you will send the data. Now here, we're trying to send data as fast as possible in a lump effectively. And then we go back into idle. In these idle areas, this is when we're going to bring some of the circuitry down to save power. Now, low power idle works asymmetrically. So effectively, if I'm sending, I can have moments of idle and active, but also in the other direction, which is clearly shown here, is that I can have moments of activity when I'm sending and I'm receiving here, but I've got an idle moment, I've got idle at this point. So basically it's asymmetric, okay? So we've got two opportunities to save power on the same link effectively. So you've got shut down on one side, active on the other, shut down on the other and active on the other. Very, very important. I know I mentioned it before, want to bring this home. Prerequisite is that auto negotiation is really important, and we must have EEE enabled prior to that. So you have to have your configuration in place and then the link goes up. By default, that none of our platforms have EEE enabled, so you have to enable it after the boot. Okay, let's look at some, I guess, typical use cases, right? So if you look today, even on a Windows device, if you look into the NIC, you'll see there's a configuration element that says Energy Efficient Ethernet, which can be switched on by administrators. If you look at our Aruba access points, so I mentioned the .3AZ earlier. So that is an energy efficient Ethernet standard. We can apply that to the Ethernet ports, and here on an AP225, which is relatively old access point, it's capable of .3AZ, and the newer ones like the 555, clearly they're enabled for it. So you could have a scenario where you have APs or endpoints in an office where they're being not utilized that much, so a quiet area. You could be saving energy on those as then when they're not being active. But remember, you can also save energy in active periods. So that's the key. So the thing about this is it's on all the time and looking to save energy both in dead time and in when you're actually transmitting data. So that's the really important part about it. It's not off, it's not on, it's active all the time. So let's get into some details. Well, I think I've mentioned this enough times, but you have to have auto negotiation on, and at link establishment, the PHY negotiates with its link partner if it's capable of EE. By default, on all of our platforms, it's not enabled. You have to do that after the fact. So once you've brought the box up, so you might decide that actually before you connect everything, you need to enable the ports that are going to use it, or you have a default script that enables those ports if that's a strategy. In terms of some of the caveats, so we only support this on copper interfaces, and if you look on the right, these are all the platforms we're supporting, and it's clearly we're going for the edge. So the edge devices, all our 6,000 platform will support it. Obviously there's a subset of the 6300s, subset of line cards, all the 6200s. So we're going for the low hanging fruit really, where all the endpoints are. Okay, So we support speeds of a 100 meg and a gig on copper interfaces. So SR ports are excluded. So you can see the 6300 SR isn't in that, even though you can put copper ports into it, right? So that's fully excluded. So you have to be careful when you're specifying, if a customer's looking for energy efficient Ethernet, you know what products you're positioning. Okay. So at the moment, we don't support LLDP renegotiation of parameters in EE, but in 10.7 we will. But it still does not mean that you circumvent this part. You still need auto negotiation. These are in-flight parameters to change what's known as the wake times, and equipment can renegotiate between themselves, but still at establishment you will still need to have EE enabled. This will not mean that you do not need to have it enabled. This is just going to make it more efficient effectively. So let's look into some configurations. I've talked a lot about some of the theory behind it, but in fact, to apply it, it's really simple. You just put in the command under the interface of interest, energy efficient Ethernet. And if the product supports it, based on the details I've provided you, it will just be configurable. Okay. So if I'm going to troubleshoot around energy efficient Ethernet, you can do show interface physical, and I think everybody should be familiar with that. But we've got now a new column inside the show interface physical that's got an EEE section as of 10.6, and you can see on these two ports I've configured it on. Okay, however, you can also see that one of the ports 132 has actually on and it's negotiated. It's the status of EE capable, and here the other port, it's off. So I've enabled it, but it hasn't negotiated it. So it could be one of two things. It could be that the endpoint doesn't support it, or I've put EEE on after I've negotiated my link. Okay. So you can drill down a bit further and you get some sort of more detailed information, I'd say. So you can see again a bit more in sort of a readable format. You can see that we've enabled EE on both these ports. However, we can see that similar situation, which are the same ports anyway, that I've negotiated on this port and I haven't on this port. And these are the actual negotiated parameters. So I can drill down even further. So you can run a diagnostic. So you can do a layer one dump, a layer one basic dump. So obviously it's all at layer one. So there's a few sections, again, some new sections in the layer one diagnostic. So looking at this port, we've got some port advertisements. So it's maybe hard to see, but it's split up in some sections. So there's usually a gap, and we've got an EE section which says, well, yep, I'm capable, I've enabled, and these are what I'm going to send to my link partner. So if I look across, this is continuation. These are the remote port advertisements. Go down a bit further, and these are the link partner. So I mentioned this LP, the link partner. Has it got these parameters? Well, actually it hasn't. It's not capable. So we don't get any information here. But if I go down to the next port, again, similar situation. EE capable, EE is enabled. I'm advertising these values of a gig and 100 meg to my link partner. And what is my link partner saying to me? Well, my link partner said to me, oh, hey, yeah, I'm able to support a gig and 100 meg. And therefore, you'll get some more parameters down here. And we will see that we've negotiated it at a gig. And actually, quite interestingly enough, from this screenshot, I've had 16 transitions. Now, this is a snapshot only in a small time. I've made 16 transitions into the LPI cycle. There's also an error count here. There's no errors here, but I think I'll be able to show you that later. So you can also go into the shell and look at the OVS agent. Okay, so this gives you pretty much exactly the same definitions and features, but in a slightly different format. So nothing extra really to be gained here. The reason I like this is because actually you can look at an individual port rather than looking at everything when you do a show interface, when you do a diag dump, sorry. So again, we've enabled E on this particular port 132. It's capable, and we've resolved it at a gig here. Okay. Interestingly enough, the amount of transitions that we've made into low power idle is 2032. These parameters here, these are cumulative, but this is a snapshot, and I'll show you that in the demo actually. And again, we get the error reports as well in the shell. And the only additional information you do get is you get a register dump, and this is about if we've got problems with the actual physical chip. We can do some interrogation on this, but this is obviously at a deeper TAC level. Okay, there's some useful resources actually that I've found, here is, you can look into depth into the standard, and here is some people blogging about energy efficient Ethernet, and I think one of them is covers the Google data center as well. Okay, so I'm going to jump into a demo now. So hopefully you can see my screen. So in this demo, I've got a 6200, okay, and I've got an AP225, which is configured for energy efficient Ethernet. And on port 118, I've got another AP. Basically, it's not configured. So we're going to use this as a control effectively, just to see the differences basically. And then we'll see some sort of live LPI cycles instead of seeing stuff statically on the on slides. So if I go across to my AP, and I'm just going to look at the wired profile now. In the wired profile, the default wired profile, I've configured. You just go into the configuration and you enable .3AZ, and you apply a commit basically. Once you've committed it, you'll see that the default wired profile here has come under the Ethernet 0. So then I can just do a show port status, and it will show me if it's got a section in it that shows you actually, yeah, you configured it, you've applied it, and I'm capable of EEE, and the ports are up. Okay, so that's just a basic look at that AP on port 117. So let's go across to the switch, and let's have a look at what's connected. So I've just, that went too quick actually. So I've just done an LLDP neighbor on both those ports, and you can see I've got that 225 here connected on port 117, and I've got on port 118 I've got the 224 that isn't capable of energy efficient Ethernet. So let's look at the config. Pretty simple. I've just got energy efficient Ethernet configured on both of these ports. Okay, so let's have a look at the interface physical. I'm just doing show interface physical. I'm just filtering on the keyword on, otherwise we'll get too much information. See that easily. think, yeah, so as I showed earlier, so this is live, obviously this is its AP on 117. I've enabled it and it's actually negotiated EEE, okay. And on 118, I've configured it on as we saw, but it hasn't negotiated it. And I know it isn't capable of it because I haven't switched it on. I don't actually have access to that port. So we can drill down just a tiny bit further, just a different way of seeing what we already have. And you can see again, it says, yes, I've enabled on both those ports, and we saw that configuration earlier. However, only on port 117, where the AP225 is connected, we've negotiated it, and we've got these wake times. It might be worth me saying these wake times, these are where the most energy is effectively used in EE. This is just at the point before the active cycle, basically, of data being sent. Okay, so I can run a diagnostics as well. It's a diag dump, and because it's physical, we're doing a layer 1 dump. The only option is basic, and this is we want to go down to port 117. Yeah, here we are, and I don't know if you remember, it's quite useful to know that it's split up. You can see different things by this little gap. There's a little split, so you know where to look effectively. So a 117, we're capable, we've enabled it. These are the advertisements at a gig and 100 meg. And then we'll look at our remote partner. It's just slightly down the screen. So the remote partner, it says it's capable and it's advertising, yes, at a gig and yes, at 100 meg. We've decided and resolved it at, we're going to work at a gig. And in fact, I think this is, so this is a bit spurious here. There's something happened here. There are some cleanups to be done in this feature, but it's saying 65,535 transitions into LPI. I think that's wrong, but this is, I'm using early bit of code, but interestingly enough, you can see we've got some errors here as well. So you could drill into that later if what to see. But I know the reason I've got the errors is this box has been rebooted quite a few times as we've upgraded software, and that can happen during the LPI cycle. If you're rebooting and you're in an LPI cycle, you can get some errors. Okay, and then port 118. We know it's not capable, so obviously we've advertised our parameters. And then if we go a bit further down, there's nothing really to see because actually that port or that link partner LP is not capable. And there's nothing to see there. So I can actually, hopefully we'll see some live data that's scrolling in terms of the figures if I go into the shell. So if I start the shell, sudo bash, and then I run this little agent on OVS. We're just going to look at port 117. Okay, so this is what I've said in terms of the format. Is I can drill down on the individual port that I want to look at, all similar information. Again, we've enabled EEE. We've got a capability. We've resolved it at a gig. Now, quite interestingly, so this is what I was saying about the counters. So these are the amount of cumulative requests that we've had, both remote and local, but these are the amount of LPI cycles I've had. Okay, so if I you can see this in the diagnostic, but obviously you see all the ports here. I can see it individually. So if I run this again, since I've been speaking, we've had 71 transitions of the LPI cycle. So that means I've made savings while I'm talking, and there's been data flowing. So if I do it again, I've had 51 cycles in those few seconds. If you take this value away from the other, so I think it was a few seconds. That's how many transitions I've had in the LPI cycle. So that's all I had to show for you today. So hopefully that was useful for you.